Now see, next sub question from question number 3, sub question 15. We have to differentiate log of root of 1 minus sin x upon 1 plus sin x. So in problem 14, we use this formula 1 minus cos theta equals to 2 sin square theta by 2 and 1 plus cos theta equals to 2 cos square theta by 2. But here instead of cos, value is sin. So we don't have the formula for 1 minus sin theta and 1 plus sin theta. Now our aim is to reduce this 1 minus sin x, 1 plus sin x, so as to cancel this square root. So we take here, first we write in solution given value as y. So write let y is equal to log of in root 1 minus sin x upon 1 plus sin x. So we take here 1 minus sin x upon 1 plus sin x as it is. Now we have to remove this root. So for that we require quantity in square form. So we multiply and divide by 1 minus sin x. So we write here 1 minus sin x upon 1 minus sin x. So in numerator we write 1 minus sin x into 1 minus sin x, that is 1 minus sin x, its bracket square upon here 1 minus sin x into 1 plus sin x into 1 minus sin x, that is of the form a plus b, a minus b. So we write this as in one root 1 square minus sin square x. So we write this as log of in root this 1 minus sin x, its bracket square, and in denominator we write 1 square as 1, that is 1 minus sin square x. So 1 minus sin square x is cos square x by using the identity. So we write here log of root 1 minus sin x, its bracket square upon here 1 minus sin square x is cos square x, because sin square theta plus cos square theta is equal to 1. So from this we can write cos square theta equals to, when transfer sin square theta to right hand side, we get cos square theta equals to 1 minus sin square theta. So we write here 1 minus sin square x as cos square x. Now both terms are in square form. So taking square root of each term, so square and square root get cancelled. We write here log of in numerator 1 minus sin x upon cos x, because square and square root cancel of numerator and square root get cancelled for denominator. Now we separate the base here. So after separating the base, we write this as y is equals to log of 1 upon cos x minus sin x upon cos x. So this we write log of 1 upon cos x is sec x minus sin x upon cos x is tan x. Now after simplifying we get this function. So we differentiate it. So we write here differentiate with respect to x. Derivative of y is dy by dx, derivative of log is 1 upon, so we write here 1 upon sec x minus tan x into d by dx of sec x minus tan x. Now we have to differentiate first function minus differentiate second function. So we write here dy by dx is equals to 1 upon sec x minus tan x into derivative of sec x is sec x into tan x minus derivative of tan x is sec square x. So we take here from both the terms sec x common. So sec x in bracket we write here tan x minus sec x, tan x minus sec x upon this sec x minus tan x. Now these two quantity are same, when we take minus sign common from numerator or denominator, so we take here minus sign common from numerator, so we write minus sec x in bracket. Here we write after taking minus sign common as sec x minus tan x upon sec x minus tan x. So this sec x minus tan x, sec x minus tan x get cancelled. So we get here minus sec x as dy by dx. So in this way we solve this. Now see next sub question, question number 16. So here log is outer function. So we apply property of log here first. So which quantity are in product form, we write in addition, and that quantity are in quotient form, we write in minus. So we first discuss here property log m into n into p upon q can be written as log m plus log n plus log p minus log q. That means this q in denominator, so we write minus sign for it, and this m n p are in numerator, so we write plus sign for that log quantity. Now here also power form is given, so we have to use here log m raised to the power n as n log m. So we write this given quantity as in solution y is equals to, let y is equals to log of 4 raised to the power 2x. So we separate the power of numerator and denominator here. So we write this as x square plus 5 raised to the power 3 by 2 upon square root of 2x cube minus 4 raised to the power 3 by 2. Now in place of p we have value 4 raised to the power 2x. In place of q we have value x square plus 5 raised to the power 3 by 2. Here we consider 4 quantity. We consider here 3 quantity m into n upon q. So we write this only. Now for this power we use this property log m raised to the power n can be written as n log m. So we write this as, by using property of log of 4 raised to the power 2x plus log of x square plus 5 raised to the power 3 by 2 minus log of root of 2x cube minus 4 raised to the power 3 by 2. So this root can be written as raised to the power 1 by 2. So we write this as, so first we write this log of 4 raised to the power 2x plus log of x square plus 5 raised to the power 3 by 2 minus log of this root. When we remove, we write this as 2x cube minus 4 raised to the power 1 by 2 bracket raised to the power this 3 by 2 as it is. So when a raised to the power m bracket raised to the power n is given, we write this as a raised to the power m into n. That means we write this 1 by 2 and 3 by 2 in product form, that is 3 by 4. So we write in next step log of 4 raised to the power 2x plus log of x square plus 5 raised to the power 3 by 2 minus log of 2x cube minus 4 raised to the power 3 by 4. Now we apply this second property for each term. So we write log 4 raised to the power 2x. That means this power 2x can be write in multiplication to this log. So we write 2x into log 4. This power we write in multiplication. So we write 3 by 2 into log of x square plus 5 here minus 3 by 4 into log of 2x cube minus 4. So here we differentiate this function y equals to. So we differentiate this. So we write here differentiate with respect to x. Now derivative of y is dy by dx. This log 4 is constant, so we write log 4 as it is, because this log 4 with this 2x, 2 is also constant, so we write here 2 log 4, and we have to find derivative of x only, because 2 log 4 is constant and this constant with variable x, so derivative of x with respect to x is 1. Then this 3 by 2 is constant and that 3 by 2 with this log function, so derivative of log is 1 upon x square plus 5. Now this is composite function, so we have to find the derivative of inner function also, that is derivative of x square and derivative of 5. So derivative of x square is twice x and derivative of 5 is 0. Then for last term, minus 3 by 4 is constant. Derivative of this outer function log is 1 upon, so we write 1 upon 2x cube minus 4 into, now this log is composite function, so we have to find the derivative of bracket. So derivative of this 2x cube, now derivative of x cube, because 2 is constant, so 2 into derivative of x cube is 3x square and derivative of single constant 4 is 0. So we write here 2 log 4 into 1 as 2 log 4, then this 2x plus 0 as 2x, so these 2 get cancelled, we get here in numerator 3x upon x square plus 5, then minus, so here this 2 into 3 6x square minus 0, that is 6x square, so we write here, when we divide 2 to this 4, so we get 2 here, so we write here 3 into 3 9, that is 9 by 2, 3x square, sorry, we multiply with 3, so x square upon 2x cube minus 4 as the derivative of given function. So we write here dy by dx is equals to. Now see subquestion 17. So here we have to use log property. So we write here property of log. So first we write here given value as y. So y equals to log of e raised to the power x square 5 minus 4x raised to the power 3 by 2 upon cube root of 7 minus 6x. So we have to apply log property here. So first we write here log of e raised to the power x square plus log of 5 minus 4x raised to the power 3 by 2. Then this quantity in denominator. So we write minus log of. So when we remove the cube root, we know that cube root of x can be written as x raised to the power 1 by 3. So we write this power of 7 minus 6x. So in log we write 7 minus 6x raised to the power 1 by 3. Now we have to write power in multiplication. We use the property log m raised to the power n as log n log m. So we write this x square which is in power in multiplication. So we write here x square into log e plus, we write this power in multiplication. So we write plus 3 by 2 log of 5 minus 4x minus, we write this power 1 by 3 in multiplication. So 1 by 3 log of 7 minus 6x. Now we have to know the concept. Log e is 1. So we write log e as 1. So first we write log e as 1. So x square into 1 we write x square plus 3 by 2 log of 5 minus 4x minus 1 by 3 log of 7 minus 6x. So we differentiate each term with respect to x. So right here differentiate with respect to x Therefore, derivative of y with respect to x is dy by dx. Derivative of x square is twice x plus 3 by 2 is constant, which is with function log. So we write 3 by 2 as it is. Derivative of log is 1 upon. So we write 1 upon iu minus 4x. Now this log is composite function. So we have to find a derivative of this bracket. 5 is single constant. So its derivative is 0 minus derivative of 4x is 4. So we write 0 minus 4. Then minus 1 by 3 is constant, which is with log function. So we find derivative of this log. Now this is composite function, so we write derivative of log first. So derivative of log is 1 upon, so we write here 1 upon 7 minus 6x, and derivative of this 7 minus 6x. So derivative of 7 is 0, derivative of 6x is 6, so we write 0 minus 6. Now simplify this. So 2x, 0 minus 4 is minus 4. So here plus minus get minus. So when we divide by 2 to this 4, we get minus 2. So we get here minus 6 upon iu minus 4x. Here this minus get plus, because 0 minus 6 is minus 6. So we divide 3 to 6. We get 2, so we write here minus minus plus, so 2 upon 7 minus 6x, which is a required derivative. Now see next subquestion 18. Log of a raised to the power cos x upon x square minus 3 bracket raised to the power 3 into log of x. So here first we write given function as y. So write let y is equals to log of a raised to the power cos x upon x square minus 3 bracket cube into log x. Now we have to apply here property of log. So apply the property. So we write this term in numerator. So we write plus log of a raised to the power cos x. Then these two quantity are in denominator. So we write minus log of x square minus 3x cube minus log of x, because this log is outer function and this we have to take log of x. Then we use the power function. So we write this cos x in multiplication. So write cos x into log a minus this power in multiplication. So minus 3 into log of x square minus 3 minus log of log x. So differentiate with respect to x this function. This log a is constant because variable is x. So differentiate with respect to x. Therefore derivative of y with respect to x is dy by dx. Here log a is constant function. Now this log is with cos x. So we have to differentiate this cos x. Derivative of cos x is minus sin x minus 3 is constant, which is with log function. So derivative of log is 1 upon x cube minus 3. Then we have to find derivative of this x square minus 3, because this log is composite function. Derivative of x square is twice x. Derivative of 3 is 0. Then minus derivative of this outer function log is 1 upon. So we write here 1 upon log x, and then we have to find derivative of this inner function log x. So derivative of this log x is 1 by x. So we write first term as minus sin x into log a. Here 3 into 2 we get 6. So we write here minus 6x upon x cube minus 3 minus 1 upon x log x. So in this way you have to differentiate the given function applying the logarithmic properties. Now see next subquestion 19. 25 raised to the power log of sec x to the base 5 minus 16 raised to the power log of 10x to the base 4. So here if you observe, here base of log is 5, here base of log is 4, and these log are of the form a raised to the power x. a raised to the power log x to the base a. So we write this as x. That means we can reduce this 25 as 5, because we write this 25 as 5 square and this 16 as 4 square. So we write given value as, so write in solution y is equals to, so we write here let y is equals to 25 raised to the power log of sec x to the base 5 minus 16 raised to the power log of tan x to the base 5. So we write 25 as 5 square. So we write 5 square log of sec x to the base 5 minus 4 square raised to the power log of tan x to the base 4. Now we use here a raised to the power m raised to the power n. So we write these two in multiplication. So we write here 5 raised to the power 2 log of sec x to the base 5 minus 4 raised to the power 2 log of tan x to the base 4. This is equal to. Now we write these two in power form. We use the concept log m raised to the power n is equal to n log m. So this n we write in power. So we write this 2 in power. So we write here 5 raised to the power log of sec x 8 square to the base 5 minus this 2 also we write in power of tan x. So minus log of tan x raised to the power 2 to the base 4. Sorry, here we write this quantity as 5 raised to the power. Here this quantity we write 4 raised to the power. We write here square bracket. Here also we write square bracket. Now we come to this concept a raised to the power log of x to the base a. Here in place of a we have value 5. So we write here this sec x 8 square. So we write sec square x minus here log of 4 to the base 4. So we write here tan x 8 square as tan square x. So we have to use here identity as 1, because sec square x minus tan square x is 1, or you can write this as 1 plus tan square theta is equal to sec square theta. So from this you get sec square x minus tan square x as 1. Now differentiate with respect to x. So derivative of y is dy by dx, and derivative of 1 which is single constant, its derivative is 0.